Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem, convert 1D array into 2D array. So it's pretty much the opposite of flattening a multi-dimensional array. So a picture is definitely worth 1,000 words here. So the idea is that we're given a one-dimensional array. It could be of any sort of length. So let's call that of length x. We want to break it into a rectangle. It has to be a rectangle. Like we can't have a piece of it missing, like, something like this, like we can't have this guy missing. So it has to be a rectangle, and the dimensions of that rectangle are going to be m by n, where these are actually parameters that are given to us. So we have to take this, rearrange all the elements so that they look like this, where the first two elements go in the first row, the second two elements go in the second row. Now imagine if we had 5 elements. It's not really possible then to form a rectangle, especially with these dimensions. So what do we do? Well, in that case, we return an empty array as like the default value. If we can form the rectangle, then we form it and then we return that. So those are the two choices that are given to us. Now, you kind of just tell me by looking at it, is there a quick rule of thumb or quick formula you could use to determine if X elements can fit inside a grid that looks like this? Well, literally just check if X, which remember that's the length of the input, is equal to n times m. If this is not the case, then we return that empty array that we were talking about, the default value. Otherwise, we actually form the rectangle, because if this is not like true, if this is actually equal, then it must be possible to break it up into rows and columns, because these are factors of that number. Anyways, I won't get into the math of that. But how exactly do we do it? Well, let's kind of pay attention to the variables we're actually going to be needing. So we're going to mainly be needing n and m. The length of this doesn't really matter because we've already confirmed this can be rearranged into a rectangle of these dimensions. So what we do is we're going to go row by row. I think it makes sense to build this thing row by row. So how do we know what's the first row? Well, we start at index 0 and we go up until the length of a particular row. M tells us the number of rows that we have. N tells us the number of columns, which tells us the length of an actual row. So we're going to go from 0 to n minus 1. That's the first row. And then the next row is going to start at n. So this is the second row. The third row is going to start at 2 times n. The fourth row is going to start at 3 times n, etc., etc. We're just going to keep multiplying that to tell us the beginning of the row. So that's easy. Right now we know the beginning of every single row that's going to go here. First it's 0, then it's going to be n, then it's going to be 2n, then it's going to be 3n, etc., etc. This tells us the beginning, right? This tells us the start. If I have the start, how do I get the end? Well, I know the length of a row is going to be n, so the end of this row should be 3 times n plus n minus 1. So this is the part that we added, n minus 1. So this is the beginning index, this is the ending index, if this one is actually being included. In Python, it would not be included, so we'd get rid of the minus 1. But anyways, that's the main idea of solving this problem. The rest will probably make more sense in the code. So I'm going to start with that if statement I was talking about. Let's just get the length of the original, which is a list provided to us. If that is not equal to m times n, then we can return immediately. Otherwise, we're going to build the 2D array and then finally return it. And we can do that like this, row by row. So I'm going to say I could say I or r. I guess I'll do r, just because it's a bit more descriptive, but this tells us the current row that we're in. For r in range m. I guess this is something I didn't talk about in the drawing, but how many rows do we have? Well, that's this many, m rows. N tells us this length of a row, m tells us how many rows we have. So we're going to build this row by row. So how do we get the current portion of the array? Well, remember, we were thinking of it in terms of pointers, the start index and the end index. The start is pretty simple. It's always going to be n times the current row that we're at. That's going to be r times n. So if we're in the first row, this is going to be 0. If we're in the second row, this is going to be n. Then it's going to be 2n, etc. End is going to be pretty easy to calculate after we have start. It's just this plus n minus 1, but I'm actually not going to have this minus 1 because in Python, we can actually do this. We can take the original list and get a slice of it from the start index to the end index, but it doesn't necessarily include this. And for that reason, we get rid of the minus 1 here. And then this slice, this tells us the row that we want to add to the result. So let's just do this. That's it. Let's run this. You can see it works and it's pretty efficient. I think in terms of big O time complexity, it is going to be the dimensions of the input n times m. I'm assuming that those are the dimensions of this. It may not necessarily be. I'm reusing these from here. You can imagine that these are different, I guess. But space, that's actually interesting. We probably could have optimized the space a bit more. We didn't need to necessarily take a slice. In here, we could have had another nested loop that would go something like this. I don't know, for I in range from the start to the end, and then appended each individual element to the result. If you want to, you can do that. I'll leave that as an exercise for the reader. I encourage you to try that out, but I'm not going to do that just because in a real interview, I could do that in 2 seconds. We all know how to do that, but I prefer this solution. I don't think the extra space that is created from a slice is really going to matter. So I'm fine with this. So space complexity though of this current solution, if we're not counting the result, it's going to be the length of one of these rows, which we established is n. So let's say the space complexity is n. If you found this helpful, check out neetcode.io for a lot more. Thanks for watching and I'll see you soon.